Welcome to Statistic Learning Session. Today we'll be talking about students' t-test for one sample and one-sided. How do we do this? In this one-sided and one sample test, we have for hypothesis test, we have two options. For null hypothesis, we have mu is smaller or equal to mu 0, and alternative hypothesis is mu greater than mu 0. This is different than one sample and two sided where mu null hypothesis was mu equal to 0, but in this case mu equal to mu 0. That's the difference between one sided and two sided test. In one sample and one sided test, we still need to create a test statistics. And how do you do that? When creating test statistics for one-sided and one sample test, we have to, it is really similar to what we did in two-sided one. But in one-sided, instead of putting minus 0, what we'll be doing is that under null hypothesis, under S0, we'll be saying is equal to mu 0. And why mu 0? If you look at the under null hypothesis, there are several values several values of mu. Why mu 0? Mu can be less than mu 0 or equal to mu 0. Why mu 0? You will choose value of mu that is closest to alternate hypothesis, and that is mu 0. That is, if this is mu 0 and this is mu, then mu is less than mu 0 and mu is greater than mu 0. Therefore, if this is S0 and this is H1, then the closest to alternate hypothesis is mu 0, and that's why we will choose mu 0 here. Now, this is equal to, this is what's the distribution of this? The distribution of this is Tn n minus 1. That's the distribution of this, Tn n minus 1. Under null hypothesis. Next step is to create a test out of test statistics for a non-asymptotic level where alpha is between 0 and 1. In this one, we reject the null hypothesis if test statistic is larger than certain threshold. What is that threshold? Can you tell? That threshold is this: Tn is greater than Q alpha. And here Q alpha is equal to 1 minus alpha quantile of what distribution? Tn minus 1 distribution. This is not a normal distribution, but is Tn minus 1 distribution, a type of student distribution. Now, what we can say is that we have derived student distribution in two ways. First, we use manipulation. We use manipulation to derive the student distribution, which is this. This is the method we use to derive student distribution, saying that, okay, this is the under null, this is xn minus 0, xn minus 0 divided by Sn and square root, and under mu 0, mu is equal to 0, and that's why we can divide both numerator and denominator by sigma, and then onwards we'll do the manipulation and bring it to such that the numerator is normal distribution and denominator is chi-square distribution divided by n minus 1, and then we can say that, okay, this is the student distribution. And there's another way to do that too. The other way to do that is we can say that the standard normal distribution, which is, we can say that standard normal distribution, we can say that xn minus mu sigma square is standard normal distribution. We can say that it's approximately a standard normal distribution. But when you replace sigma square with sigma square, that is standard deviation, sample variance, square root of sample variance is equal to, what is this? It's going to be Tn minus 1. It will not be anymore, it will not be no longer sigma, it will no be longer normal distribution, but it's going to be a Tn minus 1 distribution, and this is another way to look at it. In the end, let me quickly summarize what we learned today. We learned about one sample and one-sided students test, where we had a two hypothesis which was different from two-sided distribution, and the test strategy was also different because instead of mu equal to mu square, mu 0 is equal to 0, we did not replace mu equal to 0, we just replace that with mu 0, and then onwards we created a test statistics, and under test statistics we use the test statistics to create a test, and we rejected the test, or the test became 0 when Tn was greater than Q alpha. And using this information we created the students test for one side and one sample distribution. That's all for today. I'll see you next learning session. Thank you so much.